Hello, my name is Laurel Bingman, and I'm the Invention Education Fellow for the Society for Science. And I am so excited to meet all of you at our upcoming workshop in Jackson, Wyoming on April 26th. What this video is going to do is I hope give you a little bit of an intro, a little taste of what we're going to be experiencing in our workshop so that you have a little bit of background in what we mean by research and invention education. So, why invention and research education? When I think of my why for why I'm so passionate about this work and this form of education, I think about a quote from Richard Riley, the former Secretary of Education for the United States. He said, "We are currently preparing students for jobs that don't yet exist, using technologies that haven't been invented in order to solve problems we don't know are problems yet." And this is really at the crux of why centering a form of education that teaches students how to identify and solve problems, ask questions, get answers, and create new ideas in the world is going to be so important for them, not just right now as students, but also in order to meet the challenges and needs of a world that we haven't even imagined yet. So the next question is, what exactly is invention and research education, and why are they so great at working together to create these opportunities for students? Put simply, research can be thought of as the pursuit of new understandings, while invention can be thought of as the pursuit of new solutions. And both can work together to form a process for exploring and changing our world. The education piece comes in when we're using invention and research as a way for students to learn and as a way for students to have the opportunity to do those processes themselves. Now let's take a look at them a little bit more closely side by side. Now looking at this chart, it looks like the processes are linear. This is just to make it a little bit easier to compare them. Know that in practice, both of these processes are very much cyclical. So first, what is the starting step? In the research process, the starting step is coming up with a question, something that you are going to test, that you're curious about, the relationship between different things, or how something works. In invention, the first step is identifying a problem to solve. Now, the research question could be connected to a problem. In fact, it's very useful if it is connected to a problem in order to make it feel like there's a real world application of your research. However, it doesn't have to have a very specific problem that you're solving with your research. You could just be trying to understand a process a bit better so that later on it can inform a solution. But for both of these, students get the chance to choose a topic of their interest, something that they can be personally motivated by, that matches their own understandings and experiences, and that can be really engaging for them personally. The next step is growing in understanding what your research question or your problem is about. So in the research process, we might call this a literature review or background research. In the invention process, we call this the understanding or empathizing step. And in both cases, you are getting to build your knowledge of that topic and build also scientific literacy as you or your students are examining existing inventions, existing understandings, existing research connected to that question or that problem. And in the invention step, there's the added component of also wanting to make sure that you are interviewing people that could be affected by this problem to shape your understanding of the problem. You could also do that in the research step if you want to, but it is explicitly a part of the invention process. Next, for research, we have the hypothesis. Now that you've gotten a bit of a better understanding of the factors around your question, what do you think might be the possible answer to that question? In the invention step, very similarly, but in this case, you are coming up with what you think could be a possible viable solution for your problem. And that's the ideate step. So we have hypothesis and ideate. And in both cases, students are considering possibilities and coming up with their own ideas of what the answer or solution might be. The next step in the research process is the research plan. Now, this is especially important for any type of research, but also for if you are wanting students to participate in science fair, they must have a research plan in place in order to ensure that their experiment is going to be safe and ethical. And having a research plan is really important so that students know what it is that they need to do. They're going to be controlling for different variables, right? They're going to need to have ideas for how many trials they're going to do, perhaps what kind of statistical analysis they might try to do afterwards so that they know what type of data they need to be collecting, right? They're going to be thinking about that in the research plan phase. And that'll look different for different ages, right? But no matter what, you got to have a plan for how you're going to test your question, test your hypothesis, right? In the invention step, there's also a plan that has to be in place. But in this case, it's coming up with a design, this kind of visual prototype of what your solution is going to look like. So you're coming up with plans, a design in this case for invention. In both cases, students are going to be describing the materials that they're going to need, and they're going to be describing the procedure either for conducting an experiment or for building something, creating something that they can then test. The next step for research is doing the experiment and analyzing the data that you gather from that experiment. And very similarly with invention, you are, instead of conducting an experiment, you are building your prototype, some kind of prototype that you can test. And then you are doing the test on that prototype and you are iterating. So you are taking the results from that test and you're going back and you are changing your design, you're rebuilding something, you're trying something new, testing it again, and going through that iterative process. That iteration is absolutely present in a large scale sense with research, and students might even choose, hey, I actually think I need to tweak something a little bit in my experiment to make it work better. That absolutely can happen, but it's not necessarily expected to happen as part of the once through research process. In both cases, students are collecting data and making assessments. What that data looks like might look different for each kind of process for invention and research, but in both cases, they're getting practice collecting data and they're getting practice assessing that data, deciding what does this mean, looking for patterns, looking for things that could be different in the future, that could be tried differently in the future. And finally, we have the sharing conclusions phase of the research step, where you've done your data analysis, you've drawn your conclusions, this is what your experiment shows, this is what your data show, and you're sharing that out with other people. That could be at a science fair, it could just be in class, sharing with classmates, but you're getting a chance to share your ideas with the world, right? For invention, you're also sharing your ideas with the world. You're communicating a solution, but this might look a little bit different in the case that you're also presenting this new idea, this new invention to the world, and you're advocating for its usefulness. In both cases, you get to practice public speaking, which is such an important skill for everyone to have, no matter what they do in their life. So as you can see, there's some minor differences, but in many cases, these two processes actually align really well. Let's examine this overlap a little bit more closely, more explicitly with this diagram. So in the center, you can see the things that research and invention have in common. And on either side, you see how those things show up slightly differently for each one. So for example, both research and invention are student-centered. However, with research, that takes the form of a knowledge focus. You're trying to build knowledge and understanding of a topic. Whereas in invention, there's explicitly a user focus. You're trying to create something that people can use, that someone can use. Maybe it's a human, maybe it's not a human, but that is useful, right? You're creating something that is useful, so you have to consider how it gets used and the feasibility of someone being able to actually use your solution. Both research and invention are skills-centered. That means that you're having your students build a lot of really useful career-focused skills, life-focused skills, resiliency-focused skills that are really important. In research, that can take the form, one of the forms can be in questions asking, in knowing how to ask scientific questions to get to the root of something. In invention, that one of the forms that takes is in building problem-solving skills, which is so important for being able to examine things in your life and adapt to them and understand what is the true problem that we're trying to address here. For both of them, they are process-focused, but that process looks slightly different, as we just examined. With research, you have the scientific method, and with invention, you have a design method. For both research and invention, there is a real-life application to what students are doing. And with research, that looks like growing their understanding of a topic of interest to them or a topic of importance in the world. Whereas in invention, that looks like building a unique solution to a problem that's out there in the real world. For both research and invention, students engage in communication and practice communication. For research, that looks like explaining their findings. And in invention, that looks like pitching a product. That looks like entrepreneurial skills and entrepreneurial communication, whereas research is more of a focus on scientific communication. And finally, both research and invention engage students' curiosity, which is so important to continue fostering throughout their educational career and throughout their lives, right? In research, that looks like testing a hypothesis, and invention, that looks like meeting a specific need. Now, what I've been showing has been making it seem like research and invention are very obviously distinct things, and they do have differences. However, oftentimes you'll find your students are kind of doing both at the same time, especially when you look at the invention process. I mean, just even getting to the portion of testing their invention, that is something that is engaging those research skills, that data collection and analysis, right? Or it could come in the understanding phase. I've seen students who have started with doing an experiment to help them better understand a topic, and then through that, they have a better idea for how to create a solution to that problem. So there's absolutely overlap, and you can be doing both at the exact same time. So while we talk about their differences, also understand that you don't have to decide whether something that your students are doing is research or invention. They could be both, and that is definitely okay and very much encouraged. One final thing I wanted to talk about before handing you off to the teachers and students to talk about why invention and research is so important is comparing invention and engineering, because this is something, honestly, for myself as well, but also that I've heard from other teachers can feel kind of confusing. Like, invention sounds a lot like engineering, right? And honestly, in many cases, if you've been doing engineering projects with your students, they might have been invention projects. You just didn't call it that, and that's totally fine. But there's also some differences that I wanted to talk with you about. So first, some similarities, right? In both cases, invention and engineering, you're identifying a problem, right? Instead of identifying a research question, like with the research process, you're identifying a problem that you're going to try to come up with a solution for, right? So that is an important step for both of them. In both cases, you're also identifying criteria for success to show that your invention or design solution works, and also you have constraints on what your design can look like. In both cases, you go through an iterative design process that I think is so important for teaching students about how to learn from failure, how actually things not going exactly how you thought they would at first is not the end, but just a new beginning of something else, right? So both do that. Both are oftentimes involved in building a solution. So you learn different building skills through both of them. And both are student-centered. Students are leading the charge in identifying the problems and coming up with the solutions. And finally, both are great for science fair projects. You can use invention and engineering projects in science fair. There's no specific limitation set for either of them. Now, where does invention deviate a bit from engineering? First, there is a heavy emphasis on empathy and a user focus. What that means is I remember taking a course in college that was a global health technologies course, and it was a bioengineering course where we were trying to solve these different problems in various places in the world with health technologies and trying to kind of create different solutions for them that could work. However, something that was pointed out in that course was that very often there's an absence of consideration for the users in those cases. Now, sometimes an engineering project does make an explicit focus on the users of those designs, but sometimes it can be neglected. And then what ends up happening is the engineers kind of drop off the solution wherever it is, and they haven't consulted with the people that live there that are going to be using those technologies. And so they end up not actually being used well or not actually meeting the needs of the people who are supposed to be using it. And invention makes it very explicit. You are absolutely interviewing the people who are going to be using your product. You're making sure that their perspectives are included at every step in the invention process, and especially in that understanding step. And so that is one difference that I have noticed between invention and engineering. Although engineering can also do this, it's not as explicitly stated as it is in the invention process. Also, along that same line, there's market research that goes into invention, because it's not just about, do you have the materials to build this one thing? It is about, how can I make sure that the different people, that the people who could make use of this product can actually access this product? Is there a market for this product? So you get in those entrepreneurial skills as well. And also branching off from that, you can consider to apply for a patent. There's an emphasis on doing some patent research as part of the understanding step, not just to check that your idea is new, but also to make sure that you're learning from existing ideas. And so the patent research portion is also very explicitly an invention. Could be in engineering, but it's not as explicitly required as part of the process. And along the same lines, with invention, there's a need for it to be unique and novel. There's a focus on coming up with new innovations. Whereas with engineering, the solution for your problem might be something that exists already, and that's perfectly fine. That's great. It's not an invention though, so it's not technically invention education at that point. It's engineering. But both are important, but with invention, there's more of a focus on a unique and novel design. Also, with invention, you can qualify absolutely for invention convention, especially if you are following the invention convention guidelines and curriculum. And invention convention you're going to learn more about in the workshop, but it is something similar to science fair, but specifically for invention. And they have very specific things they're looking for. And those things oftentimes are different from a standard engineering project. So just because something is an engineering project does not necessarily mean that it will qualify for invention convention. However, if it is new, if you've done some market research, if you're employing the user focus and entrepreneurial skills, absolutely, you're doing invention education and your project can qualify for invention convention. Thank you so much for taking the time to listen to this video. I am so excited to meet you in person so that we can come up with ideas together about how to meet the needs of your students and bring invention and research opportunities to them in a way that works for you. And I hope you enjoy listening to the teachers from the Lemelson Foundation talking about the importance of invention education to them. And I also hope you enjoy listening to my students as they explain why science fair and research was important to them. I am so excited to meet you. I hope you have an amazing rest of your day, and take care. Bye.